So today we're going to cover section 3 and we're going to learn how to apply properties of chords. So we have a theorem. It's theorem 10.3. So it's the third theorem that we've learned in chapter 10. Again, the number is not important to us, but what it says is. So it says in the same circle or in congruent circles, two minor arcs are congruent if and only if, so we could reverse this, their corresponding chords are congruent. Basically what this is saying is if you have congruent arcs, then the chords are congruent. You can also reverse this and say that if you have congruent chords, then the arc measures are congruent. So this is either in the same circle or congruent circles in order for this to work. Next is another theorem. Again, the number is not important, but what it says is, so if one chord is a perpendicular bisector of another chord, then the first chord is a diameter. So in this figure, if QS is the perpendicular bisector of TR, then QS is the diameter of the circle. So the first chord, so the one that was the perpendicular bisector, ends up being the diameter. So again, remember, for something to be a perpendicular bisector, we would need to see that it's got this right angle and that it splits the segment into two congruent pieces. Because remember, a bisector will split into two congruent parts. Again, doesn't matter the number, but what it says is important. So if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So not only are these pieces congruent, HD and HF, their arcs are also congruent. So this is like the converse of 10.4. Next, another theorem. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So again, we could reverse this. So if we saw that the distance to the chords were equal, that in equal distant, then we could show that the chords are also congruent. So we can reverse this because of the if and only if. So if this is an equal distant here, and notice the right angle indicating it's a distance. So if this is the same measurement, then that tells me that these chords are also congruent. Okay, so now we'll do some examples. We have 3 examples here. Let's take a look at example A first. Now, notice they want us to find X and Y in all of the pictures. In example B here, they also want us to find an arc measure. So notice here, I've got a radius that has a length of 13. So remember, no matter where your radii are drawn, whether it's here, here, or maybe let me do it in a different color. This is a radius, and this is also a radius. So if this is 13, then I know this is 13. And notice I've got a right triangle here. So I'm going to pull it out. This is 5. This is 13. So now, since I have a right triangle, to find the value of X, I can do Pythagorean theorem. Now, for those of you who memorized your triples, you should realize that this is a 5, 12, 13 triangle. However, if you have not memorized your triples, then what we'll do is Pythagorean theorem. X squared plus 5 squared equals 13 squared. X squared plus 25 equals 169. Subtract 25 from both sides. X squared equals 144. square root both sides, and x equals 12. Now, we just learned a theorem that if we have a perpendicular bisector here, it's also the diameter. So if x equals 12, because this is a perpendicular bisector, y also equals 12. Now let's take a look at B. Notice here we've got another right triangle. Let me go ahead and pull it out. This is 60. And if you recall, this is actually a special right triangle. So here's 6, this is x. So let's go ahead and use what we learned about special right triangles. Remember when you have the 30, 60, 90? The side that's opposite 30 is a, opposite 60 is a square root 3, and opposite the 90 is 2a. These special right triangles do not go away. In fact, my Algebra 2 honors class is actually using them in the chapter we're covering now. So you will be using special right triangles in Algebra 2. So let's go ahead and see if we can figure out what x is. So I know that if this 6 is supposed to represent 2a, I'm going to set 6 equal to 2a, divide by 2, a equals 3, so 3 over here, and then the side across from 60, which is x is supposed to be a square root 3, so x is equal to 3 square root 3. And my y, which was my a, is 3. So x is 3 square root 3, and y is 3. So to find the measure of arc AB, which is right here, notice my central angle here is 60 degrees. So that would tell me that this arc right here is 60. And because these are congruent, because it's a perpendicular bisector, this piece over here is also 60. So 60 plus 60, and the measure of arc AB is 120 degrees. All right, so for C, this was the last theorem where if the two chords are equidistant from the center, then this tells me that the two chords are congruent. Now, notice this has also been bisected. So if this side is 8, so is this side. And then because they're equidistant, I know that this chord here is congruent to this chord here. So I would do 8 plus 8 to get the length of y, which is 16. Okay, so here it wants us to find the measure of arc CD. So arc CD is right here, and it's associated with 9x. So notice here, I've got, these are congruent because this is the perpendicular bisector, which also means that these arc measures are congruent. So to find the measure of CD, I'm going to set 9x equal to 80 minus x. I'm going to solve for x. So I'm going to add x. 10x equals 80. Divide by 10. X equals 8. Now the question did not ask for what x equals. It asked for the measurement of CD. So CD is 9x. So I'm going to plug in 8 for x. So 9 times 8, and it's 72. Now, if you wanted to confirm, remember that these two arcs, ED and CD, are congruent, so you could double check it and plug it in here to make sure that you do get 72. So if I do 80 minus 8, I get 72 also. So that's just a way to double check that you did get the right measurement. So the answer here is 72 degrees. Now, let's just modify this a little bit. What if I ask you to find the measurement of arc BC? What could we do? Beautiful. Because together this is the semicircle arc. So I'm going to do 180 minus 72, and that arc measure would be 108. Good. Try to think of these as like puzzles and fill in the missing pieces. Sometimes, like when you're doing the homework, it's easier if you fill in the picture first and then go back and answer the questions. That's what I found was helpful on that extra practice worksheet that you had to do last night for homework. And then one last slide here. So here in the diagram of this circle C, it's telling me that QR, that chord, is congruent to ST, and they both have a measurement of 16. They want me to find the length of CU. So we learned that either if the distances from the center to the chord were congruent, then the chords were congruent, or because it was if and only if, we also learned that if the chords were congruent, then these two distances here were also congruent. So all I need to do is set them equal to each other. So I'm going to take 2x, set it equal to 5x minus 9. I'm going to get my x's together. Subtract. Divide. X equals 3. Again, they didn't want just x, they wanted CU. So then I'm going to take what CU equals, which is 2x, replace x with 3, and the measurement of CU is 6. Okay, so that is the last example. Your homework is the 10-3 homework problems. When you come in tomorrow, you're going to do the 10-3 warm-up. We'll check the homework answers, and then I'll give you probably a quiz review for homework. And then on Thursday, we'll review for the quiz. The quiz is 10 questions, no word problems. It's mostly applications of the theorems and solving for different pieces. The quiz. 10-question quiz on Friday.